Okay, in this video we're going to talk about binomial expansion. So if we look at this, what I have here is if we had x plus y to the first, obviously that's the first power, so nothing changes, there's nothing to expand, and we would get 1x plus 1y. But if I had the binomial x plus y squared, then I would write x plus y times x plus y, and when I multiplied that all out, I would get 1x squared plus 2xy plus 1y squared. And I've done that again with x plus y cubed, so you can see here if you multiplied that all out, this is what you would have. And again, I did it with the x plus y to the fourth. I want you to see some patterns here. So what I want you to notice is that both of these coefficients are 1. And then I have a coefficient of 1 at the beginning of every row and at the end of every row. But if you look in the middle here, this is 2, and that became 2 because 1 plus 1 is 2. So that's the pattern there. And then here I have a 3 because 1 plus 2 is 3. And here I have a 3 and 2 plus 1 is 3. And then 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. Okay, and this pattern could continue. I could just keep going. And this is what's known as Pascal's triangle. So we can actually take those coefficients and we can write just the coefficients out as Pascal's triangle. And again, that would be 1, 1. And then we would have 1 on each end, but 1 plus 1 is 2. 1 on each end, 1 plus 2 is 3, 2 plus 1 is 3. 1 on each end, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4. And you see that gives me the row that I have here. I could actually just keep going and I could do the next several rows. 1 plus 4 is 5. 4 plus 6 is 10. I'm gonna get 10 here and 5 here, and I could keep going for as long as I felt like. But we don't always want to draw this out, okay? And this can keep going and these numbers can get really high. So this is gonna be very useful to us. I'm gonna show you how to do this with Pascal's triangle, and then we're gonna talk about what if we don't wanna draw Pascal's triangle out, okay? I do need you to look at a couple other things. I want you to look at the fact that this x has a first power and that y has a first power. But notice here, this has an x squared, x to the first, and no x. So this first term, which was x, started with a 2, which is this power, and then went down by 1, because there's not 1 here. This x, which has a power of 3 here, started with a 3, so 3, it has a 2 here, it has a 1 here, and there's no x here, so 3, 2, 1, 0. And the same thing with this first term x here. It had this power, which was 4. It started with the 4. 3, 2, 1, 0. So what you can see is that the exponents on the first term start with the power on the binomial and decrease by 1. So each term they decrease by 1. Well, let's look at the y. So again, the y had a 1 here, but this y, actually there was no y in this first term, so we can say it started at 0. And then we had y to the first and y to the second, which is this 2 here. And this y started with nothing, then we had y to the first, y to the second, and y to the third, and it ended with what our exponent on our binomial was. And you can see down here that it does the same thing. We have no y, we have 1y, 2 y's, 3 y's, and 4 y's. So the exponents on the second term are always going to start with 0 as the power. Okay, so it starts with 0 for my exponent and then increases by 1 each term. Okay, so that's going to be important. So make sure that you have that written down, that you know that. Okay, so now let's look at an example. So you see that this binomial has an exponent there of 4. Okay, and so I need the fourth row of Pascal's triangle, and that's going to be the one that has the 4 as the second number. So if you go back and you look at what you had on the first page of notes, it would be 1, 4, 6, 4, 1. And that's going to be that row. It has the 4 as the second power. The 4 is going to match this because they always start with 1. And that's the fourth row. Okay, so what happens is these are our coefficients when we expand this. So I would take this coefficient of 1, and then I would take my first term, which is x, and remember that the first term always starts with this power, so that's going to get a power of 4. Then I'm going to take my second term, which is positive 2, and that's going to have a power of 0. Plus, I'm going to take my second value from Pascal's triangle, the second number, and then I'm going to take my first term. And remember, I started with a 4. This is going to decrease by 1, so this is going to be a 3. I'm going to take my second term of 2, and this is going to increase by 1. So instead of 0, it's going to be 1. And then I'm going to take my next value from Pascal's triangle, and I'm going to get 6. I'm going to have my first term, and we're going to go from a 3 as the power to a 2. My second term was positive 2, and it's going to get a 2 because we were at 1 here. And then I'm going to take my next term, or my next value from Pascal's triangle, which is 4. First term, this was 2, so this one needs to be a 1. Second term, this was 2. This is going to increase to 3. And then my last value from Pascal's triangle, then I have my first term. We went from 1 to 0, and we're going to have our second term, which is going to go from 3 to 4. So what I want you to notice here is I just took all of these coefficients, those were my first value, and then I started with my first term of x, and I went 4, 3, 2, 1, 0. And then I started with my second term, which was 2, and I went 0, 1, 2, 3, 4. Okay, that's important. I also want you to notice that 4 plus 0 is 4. 3 plus 1 is 4. 2 plus 2 is 4. 1 plus 3 is 4. 0 plus 4 is 4. So these exponents are always going to add up to be that value. And some of these patterns are going to be really important for you later on in this unit. So you need to recognize those. Okay, and so basically now we just need to simplify this. So 1 times x to the 4th, and then anything to the 0 power is 1, so times 1. This is going to be 4 times x cubed times 2, which you can see that there. So plus 6 times x squared times 2 squared is 4. This is going to be 4 times x, and then 2 cubed is 8. 1 times anything to the 0 power is 1, and 2 to the 4th is 16. So simplifying a little bit further, we're going to get x to the 4th plus 4 times 2 is 8. Bring down your x squared, or x cubed, sorry. 6 times 4 is 24. And then you have an x squared in this term. 4 times 8 is 32. And then you have an x. And then 1 times 1 times 16 is 16. So this is my expansion of x plus 2 to the 4th, rather than having to write this out and multiply it all out. Okay, that's my expansion. Okay, let's look at one more of these examples, and there's a little bit more going on because my first term is 2a and my second term is 3b, but the concept is the same. Here's my exponent, so I need to go to the 5th row of the triangle, and that is going to be the one that has a 5 as the second value, so that's going to be 1, 5, 10, 10, 5, 1, and you can go back in your notes to see that. But again, here's how we expand this. We take this 1, and then we write our first term, and our first term gets this power to start with, which is 5. Then our second term, and our second term gets 0. 5 plus 0 is 5. So remember, they always have to add up. Plus, we're going to take our 5 from our Pascal's triangle. First term, decreasing by 1 gives me a 4. Second term, and I'm going to increase by 1, gives me a 1. But if you knew this one, you have to know this one because 4 plus 1, these two have to add up to 5. Taking my next number from the triangle is going to be 10. First term is 2a, decreasing by 1 gives me 3. And then increasing by 1 is going to give me a 2 here. But again, if I knew this was a 3, this had to be a 2 because those have to add up to 5. Next value from the triangle, first term. When we decrease by 1, we get a 2. Here, when we increase by 1, we get a 3. Next value from the triangle, first term, decrease by 1 gives me 1. Second term, increasing by 1 is going to give me 4. Again, 1 plus 4 is 5. And then the last value from the triangle, first term, gets 0 this time because we're decreasing again. And the second term is going to get a 5. Again, first term went 5, 4, 3, 2, 1, 0. And second term was 0, 1, 2, 3, 4, 5. So now I just got to be careful simplifying this because since this is in parentheses, this is 2a to the 5th, both of them get the 5th power. Again, anything to the 0 power is 1. Here I'm going to have 5 times. Both of these get the 4th power, so 2 to the 4th, a to the 4th, and then this is just a power of 1, so 3b. 2 to the 3rd, and a to the 3rd. 3 to the 2nd, and b to the 2nd. So you've got to be really careful to make sure you don't accidentally forget to make sure that everything, even the number, gets the exponent. Here we have 2 squared, and a squared, and then 3 cubed, and b cubed. This is just going to be 2a, but this is going to be 3 to the 4th, b to the 4th. And then 1 times. Remember, anything to the 0 power is 1, so that whole thing becomes 1, but this is going to be 3 to the 5th, and b to the 5th. Okay, and then we just need to do some math here and be very careful with this. So 2 to the 5th is going to be 32, and I'm going to have that a to the 5th there, because the other ones, when I multiply by 1, I just get the 32. Here, you would need to do 2 to the 4th times 5 times 3, which is going to give you 240, and then you have a to the 4th, b to the 1st, if you want to write the 1. Plus, again, you're doing 2 cubed times 10 times 3 squared. So you need to be careful with that, and that's going to give us 720, a cubed, b squared. Here, 10 times 2 to the 2nd and 3 to the 3rd, which is going to give us 1080, a squared, b cubed. 5 times 2 times 3 to the 4th here is going to give us 810, a, because there's only one a, b to the 4th. And then here I have 1 times 3 to the 5th. And so 3 to the 5th is 243, and then I'm going to have a b to the 5th. And so this is my expansion. But again, you can see the a value, which was part of our first term, went 5, 4, 3, 2, 1, and then no a's. And the b value, there wasn't one here, so that was b to the 0, b to the 1st, b to the 2nd, b to the 3rd, b to the 4th, and b to the 5th. Okay, but because we had numbers in here, this 2 and this 3, when we multiplied them by our numbers from Pascal's triangle, we did get different numbers here, and that's to be expected. Okay, so that is how we use the triangle to expand. Okay, so now we want to look at what if we want to find coefficients without using Pascal's triangle? What if we don't want to draw it out each time? Well, this is actually the formula here. Your calculator is going to be able to do this for you, but if you didn't have a calculator that would do this, this would be the formula. N factorial divided by r factorial times the quantity of n minus r factorial. And this is the notation we can use. So we can use this notation right here, which we read as n choose r, or we can also do this notation, and this is what it looks like on your calculator. So that's the button that you're looking for, the n choose r button. And what you need to understand is that when we do the triangle, we can use this to represent different things. So what we do is we say our first row would be row 1, choose 0. And we always start with 0 here. And then I'd have row 1, choose 1. That would be what the coefficients, what I would do in my calculator, or what I would do over here for this math to get those coefficients. So the second row in the triangle would be row 2, choose 0. Row 2, choose 1, and row 2, choose 2. Let's do one more row. This would be 3, choose 0, because it's the third row. 3, choose 1, 3, choose 2, and 3, choose 3. And what I want you to notice is that these are always going to have zeros on the bottom, and these are always going to be the same number. 1, choose 1, 2, choose 2, 3, choose 3. Okay? And this is, if we did this in our calculator, this would give us the values from Pascal's triangle. Now, how would we write this out? And here's what I want you to see. What if I were to expand something and maybe it was a power of 12 and we don't want to write the triangle out for 12? What we would do is we would start with this number, and I'm just going to write the coefficients, so we're not going to worry about what's in here. We'll do that in a second. I would write 12, choose 0, and that would be the coefficient of my first term, and then of course I would take my first term in here and it would get the power of 12, and my second term would get 0. But I'm just going to put plus, then I would have 12, choose 1, and that would be the value, that would represent the value from the triangle. And then I would have 12, choose 2, and I think at this point you guys get the idea, but doing this in my calculator would give me the numbers I needed so that I didn't have to write out the triangle. The other thing is, we could actually use this formula if we didn't have a triangle. And so remember that this number is n and this number is r. So if I wanted to do, let's do this one. If I wanted to do 12 choose 2, I would actually have 12 factorial on the top where the n is, and then I would have 2 factorial times 12 minus 2 factorial. Now the factorial just means to multiply all the way down to 1, so I'd have 12 times 11 times 10 times 9 dot 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 until I got to multiply by 1. Here, this is 2 factorial, so it'd be 2 times 1. And then inside, 12 minus 2 is 10, so it'd be 10 times, it's 10 factorial, so it'd be 10 times 9 times 8 dot 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 all the way down to 1. And what I want you to notice is simplifying this is starting at this point, these are the same. So these would actually all cancel, and what I would end up with is 12 times 11 over 2. And when I do that math, I actually just get 66. If you now go to your calculator and you find the button that looks like this, you would type in the 12 first, and then you would hit your n choose r button, and then you would type in 2, and that will give you 66. And so we don't have to do this math, we're going to do it in our calculator. I just kind of wanted to show you how that works. Okay, so now we're going to look at an example how we can use that. So this has a 4 as the power. That's not too big, so we could use the triangle, but it would be a pain to use the triangle if this was very large, 12 or 20 or 18 or something like that. So we're going to practice this without the triangle. So I would do 4, that's my power, choose 0. It's always going to be 0 to begin with. First term and my second term. Now the first term, remember, is going to get this power of 4, which is also my top number here. And this one is going to get 0. Notice that these two match, okay? Plus 4, choose 1. First term, we're going to decrease by 1, we're going to get a 3. The second term is going to get a 1 because 3 plus 1 is 4, but notice this one and this one matches. Plus 4, choose 2. 2x to the, now this was a 3, so this is a 2. But this is going to be a negative 3, and these have to add to 4, so this must be a 2, and these two match. In this case, this one also matches because 2 plus 2 is 4. But look at this next one. Okay, this is going to be 4, choose 3, 2x to the first power because we're decreasing by 1 on that first term, and the second term gets 3. 3 plus 1 is 4, and this one match. These patterns I'm trying to point out to you are going to be super important later on. 4, choose 4 would be my next one. And then 2x to the power of 0, because we're decreasing, and negative 3 to the power of 4. Again, this one and this one matches. So here for my coefficients, they all had 4s at the top, but 0, 1, 2, 3, 4 to represent the positions in my row. Okay, and now we just need to do math. So again, you're doing this part in your calculator. You're going to do the 4 and then the n choose r button and 0, and that's going to give you 1. And you'll learn that any number choose 0 is 1. Times, remember that this 2 gets the 4 also, so that's going to be 16 because that's 2 to the 4th, x to the 4th, and then negative 3 to the 0 power is 1. Here we get 4 choose 1 is 4. 2 to the 3rd, and you can't forget to do that, 2 to the 3rd is 8, and then we're going to have x to the 3rd, times negative 3 to the 1 is negative 3, and that's going to be important too. 4 choose 2 is going to be 6, and you, again, that part gets done in your calculator. Times 2 squared is 4, and then I have x squared. But on this one I have negative 3 squared, and when I square a negative number that gives me a positive, and in this case it's positive 9. 4 choose 3, this part gets done in your calculator, and that is going to give you a 4. 2 to the power of 1 is 2, and x to the power of 1 is just x. But negative 3 cubed is negative 27. Again, 4 choose 4 in your calculator, that's going to give you 1. Anything to the 0 power is 1, but negative 3 to the 4th is going to give you a positive 81. Simplifying this down, 1 times 16 times 1 is 16. 4 times 8 times negative 3 is actually going to give us a negative value. So our sign here is going to be negative, and I'm going to get 96. X cubed. 6 times 4 times 9 gives us a positive 216, and we're going to write x squared. This one though, 4 times 2 times negative 27 is going to be negative 216, and we're going to have an x next to that. And then 1 times 1 is 81. So notice here that in this case my signs are alternating, and you have to be really careful not to mess up your negatives so that you don't get this answer wrong. Okay, so if I square a negative, it's positive, but if I take a negative to an odd power, I still have that negative there, which is going to impact my answer. All right, go back and review what you need to, and I will see you in class.